let's dive into our first speaker. Gordon Brooks from Zixi is going to talk about how we can make the video supply chain smarter by tapping into the power of AI, data mining, and machine learning, and how AI and machine learning techniques can provide more robust video transport and more actionable information for operations and engineers to more effectively manage their live linear video channels. Gordon, welcome.
Thanks, Eric. I appreciate you having me.
Great to have you back here again. I know we've had you on these before, and I believe you're going to start things off with a brief presentation, and then we'll get into some questions.
You got it. Let me get that going. Welcome, everyone. Today, we're going to talk about AI and ML, and really the idea of an intelligent data platform across the video supply chain. So I have 2 slides on Zixi. I promise I won't overdo it on who Zixi is, but just to set the record straight for those who might not know. So we are a software-defined video platform. We're employed by traditional broadcasters, OTT broadcast services, and service providers, and they use us to manage, source, distribute live events and 24/7 live linear channels. Our software platform works with any IP network. With any protocol. We support 17 protocols, really almost everything out there that's carrying live and live linear. We're integrated with all the major cloud providers and run on all the rest, and integrated into over 250 companies' edge devices. So Zixi is global. We have about 100,000 instances of global of Zixi around the world in over 100 countries. We have over 700 media customers. We have 250 integrated partners. We're collecting over 3 billion telemetry data points for what we do with analytics and AI every day. And we have an unmatched network. It's a network of devices that talk to each other, but it's also content and people sharing content. So when we talk about AI in the media supply chain, we're really talking inside this blue box. There are a lot of great applications earlier in the supply chain and a lot of great applications later in the supply chain. But really what we're talking about is a smarter content supply chain, post-production, content transformation, processing, packaging, and distribution. So this is the value hierarchy, at least the way we think about it. So foundational, to have the data, and Zixi is very unique. We're collecting lots of the network, and I'll talk about that a little bit. But you have to have the data. You have to have it in a canonical form. You need to be able to do real-time processing on data, feedback loops, repository, being able to visualize it, analytics, do the AI and ML, and then automate. So that's kind of a foundational capability you need to start thinking about before you really get into the intelligent data platform. And then you start work, and that's mostly on historical data. And then you start dealing with near real-time data and real-time data, and you start out getting descriptive, doing anomaly detections and saying, here are the anomalies we're detecting, and here's where we think you should look. Comparative benchmarking. How does my stream look versus my stream over history? How does my stream look versus all the streams in my business? And how does my stream look on all my streams on fiber or on 5G, and doing that comparative analysis? Encoder quality predictions to determine whether or not you have an encoder issue before you have a problem, and things like noise reduction. And then you get into the more higher value areas like future and probability, which is predictive. So things like blast radius. So I just had an issue. What's the blast radius? Where did it impact? And just as importantly, as I design my architecture, how can I use AI and ML to plot out blast radiuses so you make them as small as possible? Predicting stream failure, transport quality scoring, service level scoring, content quality, what's going on with the actual content? Do I have jitter? Do I have blank screen? And then bringing in outside data for end user experience data to match that with what's going on in your supply chain. And then you get into really actionable items that are prescriptive. Root cause diagnostics, which is really telling you what the issue is very, very specifically, but also actually managing and controlling and doing failovers based on quality scoring and encoder bit rate and what the protocol might be telling you. And then the holy grail is really optimization. So it's the quality of the transport, it's the quality of the service, it's the quality of the content, and it's all adds up to the quality of the experience. So what we're doing really is focusing on things like anomaly detection. So we talked about looking at anomalies, but looking at really everything going on in the system and really all the potential areas that might impact a stream and letting you know when you have an issue or when it detects an anomaly, and you as the customer being able to set the threshold where that tells you something or whether it ignores it. Health scoring. So we spent a lot of time scoring the health of a stream to try and predict offline events so that to get off alerts up to 2 hours prior to an offline event. So how that usually works is you'll see scoring go down, your quality scoring go down over time, and then when it takes a sharp dip, that's when you set your threshold and go look at it. But and then it tells you exactly what you need to go look for so that you can make sure that you don't have an offline event. It's used to reduce alert noise. We talked about blast radius. Also different network types. So, what's anomalous on the open internet is very different than 5G, which is actually different than 4G, which is different than broadband or fiber that you buy in the market, and it's different than your core backbone, and then as well as low orbit satellite. So being able to have models that allow you to understand the environment that you're in. We talked about the prescriptive capabilities like failover based on content quality or failover based on visual perception, PSNR scores, SSIM, VMAP, all without looking at the source video. So using machine learning to be able to predict what the different quality scores are and how do you mix them to provide a blended answer to help you make decisions about your streams. And then root cause, which is always a huge issue that we're very, very focused on in terms of AI and ML. And then obviously operations teams. So you don't want video engineers having to run these complicated IP networks. You need operations team to do that. So AI ops and everything going on should be going on in the background and making it easier to operate these environments. So how does that look in our environment? So you have coming in any protocol in the middle of the cloud, which is a public cloud, hybrid cloud, private cloud. You have the video workflow on the bottom, right? Ingest, transcode, packaging, and then out to all these different varied sources. But you also have a telemetry workflow in your solution, managing all the telemetry, the 3 billion plus per day telemetry data points that we're pulling from our customers and using that to give them smart answers. So data sources, range from encoders and decoders and IRDs, also cloud statistics, and also external data solutions that allows you to process the data, process the event, you cache it, store it, being able to do batch and online ML processing, provide a studio to be able to then look into that data, and all that feeding what our control planes and master in our example that allows you to onboard, orchestrate, analyze, monitor, report, and run these very, very large, complicated IP workflows. And I know that was very short, but that was the point because I want to be able to chat with Eric and also take any questions if you have any.
Wonderful. I guess my first question, Gordon, as I look at this, and you talked about how large and complicated these IP systems are, who can benefit from a solution like the one you're talking about? And I guess what I'm really wondering is how big do your productions or how big does your organization have to be to benefit from what Zixi can offer?
Actually, you don't, if you really care about, if you're trying to get a broadcast quality experience, then you can have one stream or 10 streams. And using the encoder predictive analysis, looking at quality scores and making sure that you're making smart decisions to make sure. And obviously, when we architect with full redundancy and hitless failover. But the idea being that whether you're one stream or 10 streams, or if you're an NBC with 3,000 streams, being managed by Zixi, you get the benefit. But obviously, it does get exponentially more valuable as you get more complicated.
Sure, makes sense. Now, this is a topic. AI and machine learning is a topic that a lot of companies are discussing. Why is Zixi uniquely positioned to apply AI and machine learning tool sets to its customers?
Yeah, I think it's because the access to data that we have. So, and what we're doing isn't new. It's been done on the electric grid forever. It's being done quite a bit in IT. It just really hasn't been done on the video workflow, but we're collecting data from edge devices and the health of whatever's on the edge, CPU usage, memory issues. We're collecting tons of telemetry on the network. We're getting telemetry off the transport, the TR-101. We're getting telemetry off the cloud. We're getting telemetry off the endpoint. So we're pulling all this together. And so we have the data and we've been alerting on it and analyzing. So it's just common sense for us to take that to the next level because we already have the data, then to be able to provide smarter insights.
Sure, makes sense. How soon will Zixi be able to apply these tools to the broadcast workflow?
So we already have some out right now, quality scoring and things like that. We've got a major release of the intelligent data platform, April, I think it's 4th, something like that. So, I mean, we're already in beta with live data, just tweaking things. So it's imminent and on a fairly full scale. And then that gets you anomaly detection, it gets you quality scoring, things like that. And then there's a whole bunch of things we have behind that, including optimizing protocols with real-time data, and just being smarter in terms of how we're carrying content.
Okay. The last question I have for you is one that you didn't address specifically in your presentation, but I know from having worked with you in the past, we did a research report together with Streaming Media and Zixi last fall, that one of your areas of focus is 5G right now.
Right.
And I'm curious as to what role you think 5G will play in live video workflows in the future and how it will fit into Zixi's platform.
I find that an interesting subject because I think a lot of what people think of is in-venue experiences, or what you get on your phone or what you get on your tablet. All very true. But the reality is, and we actually did a survey with you on the use cases and contribution and distribution into the standard workflow. So we have a production pilot going on, which will go into production in Q2 with a major broadcaster in partnership with Verizon and AWS Wavelength Zone. And the interesting thing is, 4G LTE allows you to carry very, very high bit rate signals very, very reliably. And then you use 5G where it's available, even though it's not fully available. But all the extended 4G gives you the ability to do 8, 12, 16 meg streams. And what we're doing is we're doing a 500 affiliate satellite replacement using Verizon's cellular network.
Oh, wow.
So it's real stuff. It's happening now. And there's all sorts of, with some major sports leagues, we're doing things with, supplementing referees and things using 5G devices in stadium. And so there's a whole bunch of stuff going on, but just the core B2B workflow, we think there's lots of opportunity for 5G and 4G LTE.
Excellent. Well, that wraps things up, unfortunately. If people have any more questions, they can, of course, go to Zixi.com and get more information. And thanks for joining us again, Gordon.
My pleasure. Thank you.